Suppose the temperature outside is 5 degrees, and suppose overnight the temperature drops 7 degrees. How do we describe the new temperature? Well, from experience, you probably know that we have to use a negative number, and the negative number is -2. The temperature is -2 degrees. Now, we haven't talked about negative numbers up to this point, but we're going to in this section and in this chapter. Now, we're just going to extend the idea of the positive numbers that we've discussed before to make a set which contains negative numbers. Here's what I'm talking about. When we first talked about positive numbers, we talked about whole numbers, and we used a number line to illustrate them. And these would be the whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, and so on. And the whole numbers extend infinitely far in this direction. Well, now we're going to talk about extending the number line to the left. And when we do, we have negative numbers involved. Now, the entire set of the positive whole numbers and the negatives of those whole numbers would form the set of integers. Now, on this side of the number line, there are positive integers, and to the left of 0, there are negative integers. 0 itself is neither positive nor negative, so it's kind of the dividing mark between positive and negative integers. Now, one of the important things that we did when we talked about whole numbers before was we looked at the number line and we said, well, you know, we can establish an order relationship between any two numbers just by looking at position on the number line. Numbers that are to the right of other numbers are said to be greater than those other numbers. Numbers that are to the left are less than. So we can do that here and involve the negative numbers. Now let's practice a little bit with a couple of positive numbers, 5 and 2. Now remember, 5 lies to the right of 2, and we can locate 5 and 2 on the number line. Here's 5, here's 2. Greater numbers are to the right, lesser numbers are to the left. So 5 then is greater than 2. And we say 5 is greater than 2 like this, using this symbol. Now remember that this symbol, whether you're talking about greater than or less than, the little arrow seems to point toward the smaller number. We know that 2 is smaller than 5, and we point the arrow toward the small one, you see, and then we read it as we understand it. 5 is greater than 2, and we understand that this means greater than. Well, what about these two? -7 and 3. Well, we can locate the numbers on the number line if we'd like, but it's always going to be the case that negative numbers lie to the left of positive numbers. No matter what negative number we're talking about and what positive number we're talking about, the negative number will lie to the left. But just by the nature of positive and negative numbers on the number line, you see, and therefore negative numbers will always be less than positive numbers. What about 4 and -1? Well, once again, the negative number lies to the left, or it is less than, smaller than any positive number. Positive numbers, therefore, are greater than any negative number. So the order relationship here is that 4 is greater than -1. Now, what about these? 0 and -2. Now, 0, remember, was right in the middle between the positive and negative numbers. -2 then would lie to the left, and we can see it up here on the number line. -2 lies to the left of 0, so -2 is less than 0, or we could say that 0 is greater than -2. 0 is greater than -2. Now, these represent the most challenging kind of order relationships because we haven't seen this very much in the past. And we have a couple of negative numbers, and we're trying to decide about their order relationship. Now, just think about and imagine them on the number line. -7 lies farther to the left, you see, on the number line than -5 does. So -7 is actually less than -5. Now, even though 7 is greater than 5, -7 is less than -5. That's a very important thing to realize in this positive and negative relationship situation. Let's look at it on the number line. -7 would be out here, and -5 is right here. So -7, you see, is less than, to the left of, the -5. Consider these two, -3 with -12. Well, let's see, -3, and we could look at it on the number line, but just think about it a moment. -3 is just to the left of 0 on the number line. -12 is way over to the left on the number line. So negative 12 is farther to the left, and so it's a smaller number than negative 3. We say then that negative 3 is greater than negative 12. Now, we're going to talk about distances on the number line. And a distance on the number line of 3 would be from any number 3 units over to another number. And if I'm going, I could go in this direction and it would be 3, and go in this direction and it would be 3. Okay. Consider that distances are generally expressed as positive numbers, even though the distances might be in opposite directions. If I'm in Orlando, Florida, and I'm thinking about the distance to Atlanta and the distance to Miami, now those two cities from Orlando are in opposite directions, but we still say that the distance to those two cities is a positive number. Now, the same is true when we talk about distances along a number line, that if we are talking about a distance of 3 from 0, you see, then we could end up at 3 or we could end up at negative 3. All right, now, 3 and negative 3 are said to be opposites, you see, of one another. They are in opposite directions from 0, but they are the same distance. You can think of it like that. So 3 and negative 3 are opposites. 2 and negative 2 are opposites. Same distance from 0, but in opposite directions, you see. That's the idea. All right, a pretty simple notion. We can say then that opposites are, if we're going to list some opposites, 5 and negative 5. Those are opposites. What about 12 and? 12 would be the opposite of what? Oh, it's negative 12. It's just a negative of that number. The opposite of that number. All right, negative 8 and 8 are opposites of one another. What about negative 6? What is negative 6's opposite? Well, the opposite would be 6. Same distance on the other side of 0 on the number line is a way of looking at it. Now, when we say negative then, like this negative 4 can be read as negative 4, or it could be thought of as the opposite of positive 4. You see, the opposite of 4 is negative 4. You see, so we can read this as negative 4 or the opposite of 4. Now, that's kind of an important thing when we talk about the next topic, which is absolute value. Now, absolute value is just a fancy word for distance from 0 on the number line. How far from 0 on the number line is this number within this symbol? Now, here's the symbol for absolute value. And we can think of absolute value as just another operation symbol. You know, we have our operation symbols are basically adding, subtracting, multiplying, and dividing. But we have other operation symbols in mathematics as well. Applying exponents can be thought of as an operation symbol, and here absolute value is an operation symbol. So absolute value of 4 means what is the distance from 0 to 4? Well, that distance is 4. Now, what about the absolute value of negative 4? Well, what is the distance from 0 to negative 4? Well, that distance is 4. You see, so the absolute value of 4 is 4. The absolute value of negative 4 is also 4. Some people like to think of absolute value as meaning always positive, and that's fine if you want to think about it like that. So let's go through a few and make a calculation. The absolute value of 7, distance from 0 to 7 on the number line, oh, that would be a distance of 7. Absolute value of negative 12, 12. Seems to be a very simple idea. Absolute value of negative 9, 9. Distance from 0 to negative 9 on the number line is 9 units. You see, a positive value. Absolute value of 0, well, this is kind of trivial. The distance from 0 to 0, well, that's 0. Now, it's important to realize the difference between what we have over here and what we have here. This is the negative of whatever is represented here. The negative of the absolute value of 5. What's the absolute value of 5? 5. Apply that minus sign. You see, it's kind of like this minus sign is just carrying over to this side. And if I simplify just this business, I get 5. So that minus sign is right here. The absolute value of 5 is 5. You see, this doesn't become positive 5, and it doesn't because that minus sign is not inside here. We're not taking the absolute value of negative 5. This is the negative of the absolute value of 5. You see, that's what it means. Then here, the negative of the absolute value of 12. Well, this simplifies into just 12. And if I just bring that minus sign over, I have this. So that's the way that you want to think about it. An outside minus sign or an outside negative sign is one that's just kind of carried over. Just kind of bring it over and simplify the absolute value part. Now here, the negative of, or minus if you'd like, the absolute value of negative 3. Well, we know how to evaluate this. You see, this is just the absolute value of negative 3. Oh, that would be 3. Now let's apply the minus sign. So this is really negative 3, or the opposite of 3 if you'd like to read it that way. Now, again, on this one, same idea. You think about this part, simplify what you understand well, and just bring down the other part. So here, the absolute value of the negative 15 would be 15, and we apply this minus sign. So it's 15 for this part, and then apply the minus sign. So negative 15 is the result.